Hello, Chemistry 12. This is Mr. Chan here. This is just a follow-up lesson to the KSP introduction that I gave you. And my hope is you folks had a chance to go over some of the uh, questions that you had in your homework, as well as some time to sort of digest the video that I gave you. Now, the one thing I wanted to talk about here is comparing the solubilities using the KSP. Now, by using the KSP values of different solutes, one can determine which solute is more soluble. Now, for example, in this particular case, which one is more soluble, AgCl or AgBr? Now, if you were to take a look at the KSP values for AgCl and AgBr, you will notice that AgCl is 1.8 times 10 to the negative 8 versus AgBr, which is 5.4 times 10 to the negative 13. Now, in this particular case, what happens is, in this case here, the AgCl has a larger KSP value. And because it has a larger KSP value, therefore it has more ions in solution at equilibrium. So therefore, it's considered dissolved more or more soluble. Okay, so in this particular case, what you can see is a larger KSP value. That means there's more ions in solution, it dissolved more, or is more soluble. Now, this goes back to equilibrium. You remember equilibrium, if you have more ions, what that means is you have a larger KSP value because the more ions you have in solution, multiplied together, you have a greater KSP value. Just like equilibrium, the more products you have, the greater the K value. So that means that the equilibrium favors the products more. Now, how does that relate to dissolve more or more soluble? Goes back to Hebden when I asked you to read the book. So in this case, remember equilibrium, you have a dissolving reaction versus a recrystallization reaction. When you're looking at this equilibrium, you have to look at it from left to right as dissolving. From right to left, it is recrystallizing. So in this case, if you have a larger KSP value, that means you have more ions. And when you have more ions, that means you have more of the forward reaction or the dissolving reaction. And so that's why I can say dissolve more or is more soluble. Now, in this particular case, because the ratio of the ions in both compounds is 1:1, one can compare the KSP values to see which substance is more soluble. But if the solutes don't have the same ratio, then you would need to do calculations. What do I mean by this? So let's say we have MgOH2 versus AgCl. Now, if I wrote out MgOH2, MgOH2 let me just do it on the other side here, sorry. Let me just do AgCl is in equilibrium with Ag plus and Cl minus 1. I'm not going to do the ice tables. I'm not going to do what we did in the last lesson, but I'm just going to say KSP is equal to X squared. You compare that with MgOH2. If you have MgOH2 in equilibrium, you have Mg plus 2 and 2OH minus 1. The KSP in this case would be equal to X 2x all squared. And so this would be 4x cubed. Now, if we were to solve for this, we would look at the KSP chart, okay? And this KSP chart, I don't know if I introduced you to during the last lesson. It tells you all the solubility ion products of some solids that we use. So let's take a look at AgCl versus MgOH2. So in this particular case, MgOH2, I believe was, in this case, oopsie, 5 point, let me see here, solubility chart. Okay, it was 5.6 times 10 to the negative 12 is equal to 4x cubed. Solving for x, what I would have is 5.6 e to the negative 12 divided by 4, and then raised to the power of 1 divided by 3. I would have 1.12 times 10 to the negative 4 moles per liter. Conversely, if we did AgCl, I think I even had AgCl here, I have here 1.8 times 10 to the negative 10 is equal to x squared. So x would be square root 1.8 e to the negative 10. And square root of 1.8 e to the negative 10, I would get 1.34 times 10 to the negative 5 moles per liter. And so in this particular case, here, notice this is a larger value. Therefore, more soluble. Okay. All right, so that is the addendum. Okay, so hopefully this kind of makes sense. Again, go through this, and if you had any questions, please feel free to see me during flex time or ask me questions during class. All right, thank you very much. Have a great day. Bye-bye.